so let's start, yeah? Okay. So today we're going to go through Python for data analysis workshop. So I'm Dr. Haslina, right? Wait, it's my cursor. All right. So we're going to have like 5 different topics today. So we're going to start from the beginning. We're going to give an introduction. So what's Python? Why we're going to use Python? And this is the first step. So importing data sets. All right, because if you don't have data set, then you can't do much, right? And then after we have imported our data set, then we are going to do a bit of data wrangling. Because data, as most of you know, like some data that have been uploaded or been made public, some of them are not so clean, so a bit wild, right? So we need to wrangle them. So hence data wrangling. Or if you heard about data carpentry, okay, so that's about the same thing, but data wrangling sounds a bit more swashbuckling, right? Okay, so then we're going to have a little bit of lecture, a bit, and then we're going to do hands-on. Okay, so after we have wrangled the data, make sure that everything is okay. Okay, there's no unexpected data. Then we're going to explore our data. So this is the third part. Okay. So this is the third part where we're going to explore our data. Okay, exploratory data analysis, or short form EDA. Okay, we're going to explore data. So what is the characteristic? Can I use a linear regression, multiple linear regression, a polynomial? Okay, because you need to know the characteristics of your data to be able to use the correct methods. Okay. Now, next, after that, we're going to, after we have explored our data, we have identified which method is the best method to use with our data, we're going to develop our model. So that's step number 4, or topic number 4. We're going to develop our model. Right. Now, after we have developed our model, okay, we have some insight, of course, and the final part is model evaluation. Okay, we're going to evaluate a model, whether it's okay or not, whether there are some biases, all right, and how are we going to handle those biases. Okay, now, we move on to the next part, which is importing and exporting data in Python. Okay, so when we import data, so import data, I think all of you know, it's the process of loading and reading data into Python from various resources. Okay. Now, there's 2 important properties that you should look at when you want to import data. First is the format. Okay, so there's various formats that you can import data in Python with. So that's the CSV, our data set is comma separated value. You can use JSON, Excel, okay, and so on and so forth. All right. Next, we have you have to be aware that the second important property is you need to know the file path of the dataset. So if it's on your computer, what is the file path? And if it's on the internet, okay, what is its URL? Okay, and we're going to use the second part. So we're going to just use to get our to import our data from the internet. Let's start, right? Okay, pandas library. So what we need to do, okay, we can import our pandas library. So import pandas SPD. So just click on this. Run anyway. Okay. So just click on this. Okay. And if you move on to the next cell, you will see that the play button has now changed to square bracket 1, meaning that that's the first code cell that has been run on this Jupyter notebook, right? So to keep track. Okay, now we want to read our data. So how do we read our data? We use the pandas read underscore CSV function. Okay, so in the bracket, we put the file path along with quotation mark so that pandas will read the file into a data frame from the address. Okay. All right. So because data, as we have seen in the previous slide, it does not include header, we can add an argument headers equals none. inside the read underscore CSV method. So pandas will not automatically see the first row as header. Okay, but how are we going to add it? Okay, we're going to look at that later. Okay, so you can also assign the data set to any variable that you create. Okay, all right, so this is our second cell. All right, so let's run this. You can either just click on this or you can control enter. Okay, so cell has not been executed in this session. So let's run this. Okay, we have we import pandas SPD. And how can we read the online file? We read the online file by the URL that we have that is provided above, and we are going to assign it to the variable df. Right, so this is the path. Right, so remember to put put this. All right, and then so for this one, PD read CSV. So other path. So we put, okay, there's no header. Right, so let's run this. All right, okay. So, all right, so it has changed to number 3. All right, so it has read the data from the URL and put it in our variable df. Okay, so after reading the data set, we can use the data frame dot head n method to check the top n rows, like how many rows that you want to see. Okay, to check the top n rows of the data frame. Okay, so n is an integer, so you can put 5, 10. Okay, right? And so if there's a head, there's also a tail. Okay, so if you want to see the bottom part of your data frame, you can put tail. All right, so let's show the first 5 rows using data frame head method. All right, so let's just run this. All right, so as you can see, okay, so data preprocessing. This is really important because if you don't preprocess your data correctly, then you will use the not so good or a bit dirty data to do your model, to create your model and then to do your prediction. And it's not going to give you like the best model because well, the data that you use to generate your model is not a clean and good data representation of your data. Okay, so we need to do data processing. Usually a lot of people we do this we spend more time on this. Okay, and rightly so, because you want to make sure that your data is is clean. Okay, there's no unexpected booby traps. Okay, there's no mismatch data type. Okay, so what is data preprocessing? So it's the process of converting or mapping data from the initial raw form into another format. Okay, now the format should be able to be used for data analysis because that's what we basically want to do. We want to analyze our data. Okay, so this is also known as data cleaning or data wrangling. Okay, or some people I've seen they use the term data carpentry. Okay, all right. Okay, now as you can see, several question marks appeared in our data frame. Now these are missing values which may hinder our further analysis. Okay, okay. Now, how do we deal with missing data? Okay, so previously we have gone through, so we can either drop the data, drop the whole row, or drop the column, okay, or replace the data. Okay, we can replace it by mean, by frequency, or other functions. Okay, now whole columns should, okay, now how do you know whether it's okay to drop whole columns or just rows? Okay, so whole columns should be dropped only if most entries in the columns are empty, meaning that it's not really informative for us. Okay, but in our data set, none of the columns are empty enough to drop entirely. Okay, so now we have some freedom in choosing which method to replace the data. Okay, missing values done. Now look at data format. Okay, so the last step in data cleaning is checking and making sure that all data is in the correct format. Okay, whether it should be in integer, float, text, or other. Okay, so this is in normal Python. let's list the data type for each column. Okay, data types. Like this. Alright, so we see. Alright, something is wrong here. Prices object. Aha. Some columns are not of the correct data type. Okay. Numerical variables should have a type float or integer, and variable set string object. So we see bore and stroke. So let's see bore and stroke. Bore and stroke here is type object. Okay. Okay. So it should be float or integer. However, object. Okay. As well as our target. Okay. Most important thing, object also. We should change it to float or integer. Okay. Now, we have seen our data type. We have seen some of the data type incorrect. What can we do? Let's change it. So, convert data types to proper format. All right. So in this module, we're going to cover the basics of exploratory data analysis using Python. So, exploratory data analysis, or in short, EDA. Okay, I still can't. It's a bit of a tongue twister for me. Okay, EDA is an approach to analyze data in order to summarize the main characteristics of the data to gain better understanding of the data set. Okay, and then we want to uncover relationships between different variables and extract important variables for the problems that we are trying to solve. All right, so the first one is descriptive statistics. Okay, so descriptive statistics is basically to describe the basic features of the data. Okay, and give short summaries about the sample and the measure of the data. All right, so how are we going to use this in Python? So let me show you a couple of different useful methods. So one way in which we can do this is by using the describe function in pandas. Now, let's look at basic of grouping. Okay. Okay, so how can we use grouping in Python? So we use pandas. So this can be done using the group by method. Okay, so the group by method is used on categorical variables. Okay, it groups the data into subsets according to the different categories of that variable. So you can group by a single variable or by multiple variables by passing in the variable names. Okay, so now let's look at correlation. So what is correlation? It measures to what extent different variables are interdependent. Okay. In other words, when we look at two variables over time, if one variable changes, how does it affect change in the other variable? Okay. Now, in data science, we usually deal more with correlation. Now, let's look at the correlation between engine size and price. Now, this time, we'll visualize these two variables using a scatter plot and an added linear line called the regression line here. Okay, which indicates the relationship between the two. Now, the main goal of this plot is to see whether the engine size has any impact on the price. So in this example, you can see that the straight line goes through the data points, okay, and it's very steep, okay, which shows that there's a positive linear relationship between the two variables. With increased value of engine size, value of price goes up as well, and the slope of the line is positive. So there is a positive correlation between engine size and price. And now, let's move on to ANOVA, analysis of variance. Okay. So here we'll study the analysis of variance. So assume that we want to analyze a categorical variable and see the correlation among different categories. Okay, for example, let's look at our car data set. So the question that we want to ask is how different categories that make feature as a categorical variable has an impact on price. Okay, that's our question, right? So the diagram shows the average price of different vehicle makes. Now, we do see a trend of increasing price as we move right along the graph. So here, okay, goes higher. But which category in the make feature has the most and which one has the least impact on the car price prediction? Okay, so to analyze categorical variables such as the make variable, we can use a method such as the ANOVA method or analysis of variance. Okay, so ANOVA is a statistical test that stands for analysis of variance, right? So ANOVA can be used to find the correlation between different groups of a categorical variable. Now, let's perform an ANOVA test to see if our intuition is correct. So, in the first line, we extract the make and price data. Okay, and then we'll group the data by different makes. Okay, and then the ANOVA test, okay, can be performed in Python using the f_one_way method here. Okay, so this is a built-in function of the SciPy package, Scientific Python. So we pass in the price data of the two car make groups that we want to compare and calculate the ANOVA results. Now the results confirm that we guessed it first. The prices between Hondas and Subarus are not significantly different as the F-test score is less than 1 and the p-value is larger than 0.05. Okay, but okay, the prices between Hondas and Jaguars are significantly different. Okay, since the F score is very large. So F equals to 401 and p-value is less than 0.05. So all in all, we can say that there's a strong correlation between a categorical variable, okay, and other variables if the ANOVA test gives us a large F-test value and a small p-value. Okay, now this concludes the lecture.